Distinguished guests, ladies and gentlemen, good afternoon. I'm from Orange Research Institute, Orange Hydrogen Research Institute. My name is Meimei. Today I'll be talking about the application development trend of PGM in hydrogen energy industry. I will be firstly walking through the current status of hydrogen industry development, followed by an overview introduction of PGM application in the hydrogen industry, and lastly I'll be covering the market demand and forecast. So for the first chapter, status quo. In the world of electrolyzer for the production of hydrogen, in terms of the installed capacity of electrolyzer is one important indicator of the current capacity. So currently, thanks to the support of hydrogen energy policies from governments around the world, and companies emphasize on the transformation development to green energy, the global electrolyzer market is seeing a steady increase. We'd expect that by 2030, global installed capacity of electrolyzer will reach 103 GW, where alkaline electrolyzer will reach about 60% of them, and the PEM electrolyzer will account for 40%. Now let's shift gear to China. In 2024, China's installed capacity of electrolyzer was around 1.3 gigawatts, with alkaline electrolyzer was about 1.2 gigawatt, and PEM electrolyzer was about 0.1 gigawatt. We'll expect that by 2030, China's installed capacity of electrolyzer will reach 25 gigawatts, of which alkaline electrolyzer will reach installed capacity of 21 gigawatt, and the PEM electrolyzer's installed capacity will reach 3.8 gigawatt. Now let's take a look at the sales of hydrogen fuel cell vehicle in the world. Starting from 2022, where a peak was reached, we have seen a dwindling trend over the past couple of years. 12,000 new hydrogen fuel cell vehicles were sold globally in 2022. With the exception of Japan, all other countries are seeing the sales of their hydrogen fuel cell vehicle going down. In particular, in Germany, they canceled subsidies to hydrogen fuel cell vehicles in 2023, and the sales of hydrogen fuel cell vehicle in Germany was zero in 2024, vis-a-vis about 7,000 in China. Going forward, with companies with technological progress and hydrogen charging infrastructure becoming more extensive, we'd expect that 1.85 million hydrogen fuel cell vehicles will be sold in the world, and China's sales of hydrogen fuel cell vehicle will exceed 600,000. Next up, please allow me to give you an overview of PGM application in hydrogen industry. So PGM, in terms of where it is used in the hydrogen-related industry, fuel cell vehicle and PEM electrolyzer are the two most sophisticated use cases. In addition to that, in alkaline electrolyzers, a couple of companies have also commercially used PGM in their alkaline electrolyzer. PGM used as catalyst, they form an important component of PEM electrolyzer as well as alkaline electrolyzer. In the alkaline electrolyzer, it catalyzes the reduction reaction, and currently mainly palladium and nitride catalysts are used as mainstream because anode reaction is more complicated than cathode reaction. So in anode, use cases is more predominant, and cathode is also the focus of research of the industry. Currently, platinum loadings in platinum nitride catalyst, so platinum accounts for about 40 to 50%, and in PEM electrolyzer, its reaction is opposite to fuel cell, which means that it mainly promotes reactions at the cathode, at the anode, and oxygen-taking reaction at the cathode to improve the efficiency because, again, anode is more complicated than cathode. So for anode catalyst, mainly iridium dioxide is the mainstream, and iridium loading is about 70 to 80%. The highest sales, or 75%, iridium-containing catalyst sells the best. In the alkaline electrolyzer, mainly currently they do not use PGM, but the trend is to go towards PGM use. The addition of a small amount of precious metal in alkaline electrolyzer can help to make sure the cathode electrode can reduce the over potential, thus improving the current density and hydrogen production efficiency. Next up, let's take a look at PGM's loading and how the loading has been evolving over the years. So in electrolyzer, in terms of anode catalyst, 1 to 2 micrograms per centimeter squared, and the number is expected to go down to 0.6 milligrams mg of iridium per square centimeters by 2030. In the alkaline electrolyzer, or ALK, in the cathode catalyst, so currently mainly ruthenium and platinum are used. Rarely companies use iridium catalyst, and platinum's loading is around 0.5 to 1 gram, and the expectation is that the number will go down to 0.1 to 0.2 gram per kilowatt by 2030. As for ruthenium loading currently stands at 12 grams per square meters, and the number is expected to go down to 8 by 2025. In the field of cathode catalyst, the mainstream catalyst, which contains platinum, and the platinum loadings is expected to be lowered to 0.088 mg platinum per square centimeters by 2030, and the number in China currently stands at 0.3 to 0.4 grams of platinum per square centimeters, and the number is expected to go down to 0.1 mg by 2030. So because of the proportion, the loading of platinum and iridium is a key research focus of the industry. By adding nickel and cobalt as well as other types of stable metal, or changing the structure of the substrate, thus they are used as a way to reduce the loading of PGM. Some companies are doing research in that respect, but none of these companies have released any of their products. In terms of iridium-based catalyst, because iridium-based catalyst has a relatively higher OER activity and its price is about 1/10 of iridium. Thus, it is regarded as a potential substitute of iridium. However, further studies need to be done regarding the stability of ruthenium, and in particular, over the last year, ruthenium price has increased by 1.5 times. Thus, we shall also consider other alternatives. At present, PD is one of the powerful options to replace iridium and promote platinum in existing hydrogen catalyst. So iridium plus PD, the performance of IRPD catalyst in PEM electrolyzer shows lower voltage at 2 ampere per square centimeters testing. Some degradation pace at that of the best IRO2 benchmarks. The addition of PDIR catalyst compared with oxide-based catalyst under same conditions, the electric current needed is lower, thus reducing electricity consumption. In addition to that, the degradation pace for IRPD 3.1 reduction or degradation per hour on average, which means that this type of catalyst has a longer durability. In addition to a PEM electrolyzer, PD also can play a very important role in ALK. According to the latest research of Nornickel, the introduction of PD into the cathode catalyst can also reduce the cathode overpotential, and the PD loading can be 0.18 mg per square centimeters. By adding that amount of PD, the consumption of electrolyzes energy by 3%, which means that by 2027, energy consumption for electrolysis will be reduced by 10%, with the PD loading on the cathode being less than 0.1 mg per square centimeters. In addition to reducing energy consumption and improving the efficiency of electrolyzer, PD can also reduce the LCOH of hydrogen by 6%, thus reducing the operational cost. Lastly, let's take a look at the third part, market demand and forecast of PGM in the hydrogen industry. In the global PEM electrolyzes hydrogen production field, currently the iridium loading capacity of commercial PEM electrolyzers sales worldwide is about 0.4 gram per kilowatt, and by 2030 the figure is expected to go down to 0.12 mg per watt, and by 2030 global market demand for iridium as an anode catalyst in PEM electrolyzers is expected to reach approximately 4.8 tons. By replacing 30% of iridium with PD, the market size of PD will reach approximately 1.4 tons. In the area of fuel cell, the current platinum carbon catalyst platinum loading has reached 0.3 gram per kilowatt and is expected to decrease to 0.1 gram by 2030. And by replacing 25% of platinum with PD, the market size for PD is about 4.8 tons by 2030. In ALK, PGM containing catalyst, its penetration in China is expected to increase from the current 1% to 15% by 2030, and the platinum loading will reduce from the current 0.5 to 1 gram per kilowatt to 0.1 to 0.2 gram per kilowatt by 2030. According to estimate, by 2030, the demand for platinum will be approximately 368 kilograms, given or using the assumption that the platinum loading will be high, then the demand will be 368 per kilogram. For palladium catalyst, if the palladium catalyst is to be introduced into the market and used to replace platinum, then PD's demand will increase by 8%.
Thank you so much. That's all for my sharing.